now we are in the second class of signal flow graph and block diagram reduction. So here we will see some more problems which are already been asked in GATE. So the fifth problem is, in fact the first problem of second class is the system shown in figure below. This is the system shown in figure below, and this question has been asked in GATE 2007. Now the question is saying that this system can be reduced to the form, this is the form with, there are four alternatives given, and the question is asking about that which alternative will be correct one. So let us try to solve it. So actually this system is reduced in this form. So now what we have to do, let us try to solve it by signal flow graph. So let us see how many input and how many output, how many forward paths are here. So let us name the different points in the figure. So let us name it as C. This is C. Let me write it as C because this is output. So let me write it as CS. Let me write it as US. Okay. Now let me write this point as let me write this point as A, capital A. Okay. Let me write this point as capital A and this point as this point. Let me write this point as or you can say we cannot, there is no need to write this point because this point, this branch is going in the summing branch, so we can directly say that this point is A and this point is, let me write this point as B. Okay, this summing block as B, point B. So this point is A, this point is B. Okay. Now let me write this point as C. This is a takeoff point, this point as C. Okay. So if this point is C, then let me write this point, if this point is C, so let me write this point as D, this summing block as D. So if we say AD, then this path will it will denote this path. If we say CD, then it will be denoted by this path. Okay. So this summing block as D. Now let me write this summing block as E. This summing block as E. Okay. Now let me write this takeoff point. This is a takeoff point here also. This takeoff point as F. Okay. Now let me write this takeoff point as F. So now I think there is no need to denote this point because F can be directly connected with E and F can be directly connected with B also. So there is no need to give any name of this point. So and finally this point I have F, this point as G. This is a takeoff point, so this point as G. Okay. So now our the naming of different points in the diagram is complete. Now let us see what are the forward paths between the input US and output CS. So forward paths. Let me write here the forward paths. Forward path. Let me write here path gains. And let me write here delta associated with path. Delta associated with path. Okay. Now what are the forward points? Let us try to count the forward point paths. So the first forward path is U, A, B, E, F, G, C. Okay. So the first forward path is U A B E F G C. Now it will have let me write its path here as P1. So P1 will be nothing but what will be P1? U A. The path line between U and A is this is 1. Okay. The path line between A and B is C naught. Okay. This is C naught. The path line between B and E is 1 by S. So 1 by S. Okay. The path line between E and F is again 1 by S. So again 1 by S. Okay. The path line between F and G is P. So it will be P. So now how much it will be? So it will be C naught P divided by S square. So let me write here C naught P divided by S square. Okay. Now what is the second forward path? So the second forward path will be U A. So because we have to always always start from U A B and let me see if there is any other path, any other forward path from here or not. So U A B E F G C I have already written. So is there any other forward path? Is there any other forward path? No. So now we have to write U A and C D U A. You can say D E F G C. Okay. So U A D F G C. U A D E F G C. Let us denote its path line by P2. So what will be P2? Now P2 will be nothing but it will be between U and A the path line is 1. Between A and D the path line is C1. Between D and E the path line is again 1. Between E and F the path line is 1 by S. Between F and G the path line is again P. So it will be nothing but C1P divided by S. Okay. Let us see whether any more paths exist or not. So as we can see there is no more forward path. So now let us see what are the loops. So loops, let us write here loops. So what are the loops? So as we can see the first loop is F E F because F again E and F. This is the first loop. Second loop is F B E F. So first loop is let me write first loop. Let me write here loop and here loop gains. Here we will write loop gains. So the first loop is E F E. E F E. This is E F E. Okay. So if this is the first loop, then its path line will be how much is its path line? Let us denote it by L1. L1 will be so from here to here it is from E to F it is 1 by S. From F to E, from F to E again it is minus. This block has gain A1 and this is going in the summation point after negating it, means after making it negative. So it will be minus A1. So how much it will be? Minus A1 divided by S. Let us find the other loop. So other loop is F B E F. F B E F. So other loop is F B E F. So if F B E F. So what will be the loop gain? Let us denote it by L2. So loop gain will be from F to B. It will be minus A naught. Minus A naught, because here from F to B there is a block A naught and it is going by negative after making it negative. So it will be minus A naught. Okay. And from B to E 1/s. So it will be 1/s. And from E to F again it will be 1/s. So it will finally it will come minus A naught divided by S square. Okay. Now what will be the other loops? So other loop will be G C. Okay. G C, then B, then E, then F, then G. This one G C, capital B, capital E, F, G. And what about another loop? Another loop will be G C. Now not B. Now it will be D. Okay. So there will be 4 loops. Let me write one by one. So G C B. Okay. Then E, then F, then G. Okay. So what will be the loop gain for this loop? So let me denote it by L3. So from G to C, the loop gain will be, the path gain will be 1. From G to C. From C to B, the path gain is B naught. B naught. Okay. And from B to E, the path gain is 1/s. Okay. From E to F, the path gain is again 1/s. From F to G, the path gain is P. So how much it will be? B naught P divided by B naught P divided by S square. Okay. Now the fourth loop is, which one is the fourth loop? G C. Let me write G C and G C, capital D, capital E, F, G. Okay. So G C D E F G. So what will be the path loop gain? So let me denote it by L4. So L4 will be nothing but from G to C, the path gain is, from G to C, the path gain is again 1. From C to D, from C to D, the path gain is B1. Okay. From D to E, the path gain is again 1. From E to F, the path gain is 1/s. Okay. And from F to G, again path gain is P. So it will be B1P by S. B1P divided by S. Now we have calculated all the path gains, all the loop gains. So let us see whether any of these two loops, any of these loop touches the two paths or not, the two forward paths or not. So each forward path contains the point E, and in each loop there is the point E is there. So all the 4 loops are touching the two forward paths. So there is no loop, there is no such loop which is non-touching these two forward paths. So delta associated with these two paths will be, let me write here delta 1. So delta 1 will be nothing but it will be 1, and delta 2 will also be nothing but it will be 1. Okay, it is, I think it is clear to all of you. So we have calculated delta 1 and delta 2. Now let me calculate what is delta. So let me write here what is delta. So delta will be nothing but before calculating delta, let me check whether there are two loops which are non-touching or not. No, because all these four loops are touching each other. Why I am saying this? Because all loops are containing the point E. So there is no such loop. There are no such two loops which are non-touching to each other. So the delta will be, let me write here the delta. Let me write here delta. So delta will be nothing but 1 minus L1 plus L2 plus L3 plus L4. Okay, it will be 1 minus L1 plus L2 plus L3 plus L4. Okay, I think it is clear to all of you. Now what will be delta? So if we write L1, L2, L3, L4, so it will be 1 plus A1 divided by S plus A0 divided by S. Okay, minus B0 P divided by S square. A0 divided by it will be S square minus B1 P divided by S. Okay, now we have calculated delta. Now what will be the transfer function in this case? So the transfer function in this case will be nothing but, so let me write the transfer function. So transfer function will be Ts equal to nothing but sigma Pi delta I divided by delta. So it will be nothing but C0 P divided by S square multiplied by 1. So if you multiply it by 1, then it will remain the same. Again C1 P divided by S multiplied by 1. It will get multiplied by 1 divided by 1 plus A1 by S plus A0 by S square plus minus B0 P by S square minus B1 P by S. Okay, so this will be the transfer function. Now let me wipe out so that we can write more things. So let me wipe out here these things. Now let us see what will be the transfer function Ts. So Ts will be from here to here. So Ts will be, what will be Ts? So Ts will be nothing but it will be, if we multiply by S square, then it will be C0 P plus C0 P plus C1 P S divided by, it will be S square plus A1S plus A0 minus B0 P minus B1 PS. Okay. Now if we take S as common, then it will be what it will be, if we take p as common, so it will be c naught plus c1s p divided by in uh, uh, denominator, if we take s square plus a1s plus a naught common, then it will be uh, like s square plus, let me write first, then we will take common, plus a naught minus b naught p minus b1 ps. Okay, so here p is that there are only two terms which are containing p. Okay, so let me uh, divide the whole term of denominator, or we can say let me take common this term, let me take this term as common, so it will be c naught plus c1 s multiplied by p divided by s square plus a1 s plus a naught, this multiplied by 1 plus 1 minus b naught p, let me take p as common, so b naught plus b1s, okay, p divided by s square plus a1s plus a naught. Okay, so this will be the final transfer function for this system. Now let me calculate what will be the transfer function for this system. So let me make here arrow. Now the transfer function for the second for the reduced system, here let me write the transfer function for this reduced system, for the reduced system will be, what will be, so transfer function will be, since here it is in feedback and it is in positive feedback, so we can directly write it as this one as yp, so yp gs divided by 1 plus gs into hs, so here it will be 1 minus gs into hs, because for this block, let me write for this block we can directly write it as here g will be yp, y multiplied by p, so yp divided by 1 minus ypz. Why I am saying minus? Because it is positive feedback. If there would have negative feedback, then we will write then we have to write here positive sign 1 plus ypz, because in place of g we are writing yp, and in place of h we are writing z. Okay, now I think it is clear to all of you. So the transfer function for this reduced system, let me write it as t dash s. So t dash s will be, this will be nothing but x multiplied by this one, so x y p divided by 1 minus y p z. Now if we compare, so this is equation 1, and this is equation 2. Okay, let me write this. If we compare t and t dash, because both are same, let me write it also as t, and let me wipe out this also. Now if we comparing 1 and 2, so comparing 1 and 2, comparing 1 and 2, we can write, we have what we have, xyp equal to, here also it is xyp in the form xyp, and so this will represent xyp, okay, and 1 minus yzp, this will represent 1 minus yzp. So xyp is nothing but it is c0 plus c1s p divided by s square plus a1s plus a0. So p will cancel out each other, okay. So xy will be c0 plus c1s divided by s square plus a1s plus a0, okay. Now yzp, what will be yzp? Now yzp will be nothing but it will be b0 plus b1s p divided by s square plus a1s plus a0, okay. Now again p will cancel out each other. Now we have got the value of xy and yz. So if we divide these two terms, then we will get the value of xyz. So now xy divided by yz, this will be equal to c0 plus c1s divided by s square plus a1s plus a0 multiplied by s square plus a1s plus a0 divided by b0 plus b1s. These two terms will cancel out each other. Now we are left with c0 plus c1s divided by b0 plus b1s, okay. Now it is, and here it will be xyz, x divided by z. So let us try to find out which option is correct. Now by these informations, let us try to find out which option is correct. So x divided by z is equal to c0 plus c1s divided by b0 plus b1s. So c0 plus c1s x is, and x divided by z. No, this is not correct, because here s is related with b0, not b1. So option number A is not correct. Option number B is also not correct, because if we take the ratio of x and z, then this will not come this much. So here c1s, okay, plus c0 and z is 1. So again the ratio will not come c0 plus c1s divided by b0 plus b1s, okay. In option number D, c1s plus c0, and here b1s plus b0, and so it's okay. The ratio is coming, x and z are coming. So x like this, and what about y? If x and z are we are knowing x and z, then we can calculate from here that x, y, z we are knowing. So we can calculate y from here itself also, and y will be x into y, this x into y will again be this one. So okay, so option number D is correct one. So this option number D is correct one. Okay. Now at the last of the lecture, I would like to share one of the most important thing to you people, that if you like my video, then you must subscribe my video, so that there is no need to search out new video. Automatic upload will come if I upload the new videos. What you have to do, it is very simple. There is a circular logo coming in right of me. You have to just click on that to subscribe.